What's up, party people? It's your boy Optimus Code. Welcome to the channel. All right, so today we're going to learn more about some software specific terminology, and especially when it comes to video games. You keep hearing people talk all the time about the word build, and they'll say like a cross-gen build or the PlayStation build or the Xbox build or a PC build, so on and so forth. And they try to make correlations between the builds and all of these different things. But at the end of the day, they don't even know what a build is, right? It's just a term that they have heard that they repeat. They try to repeat it in context without actually understanding what it is. So in this video, we're going to go over exactly what a build is, what all is in a build, the process of creating a build, and all of that good stuff. And if you stick around to the end of the video, you know there will be a quiz. And if you pay attention during the video, you should be able to pass the quiz at the end. All right, so let's discuss builds. Now, here's the thing. In order for you to really understand this video, there's a video that I made previously about compilers and assemblers. And you really need to watch that one first because it covers all of the background that you need in order to understand what happens with the build and what all goes into a build. So I will put that video on the screen and make sure you look at that one first so it'll be easier for you to understand what's going on in this video. Oh, and one more thing. There will be a quiz at the end of the video. Every video on this channel has a quiz at the end, so make sure you stick around to the end and see how you do on the quiz. All right, let's discuss builds. Okay, so we start out with the code file and we need to get this into machine language format. So obviously we have to run this through the compiler. And once that is done, we end up with what's known as object code. Now the job isn't done there because once we have generated the object code, then we still need to bundle everything up into what's known as an executable. And this is where the role of the linker comes in. A linker is a special program which basically takes a bunch of binary modules and combines them into one single binary file known as an executable. And the name of this process is called linking. And linking happens usually at the same time that you compile, like it's the last phase in the compiler step. So usually when people say compile, they usually mean compile and link as one operation, although technically those are two separate operations. The linker is separate from the compiler, but going forward, when we say compile, we'll just mean the complete process of compiling the code and linking it together into a single executable. Then that executable obviously is loaded into RAM when you're ready to play your game. Okay, so now what goes into a build? Well, that executable file that the linker created, that's what's called a build. And in our example here, there's only one file that's in our build. This one source file was compiled and linked into a single executable, and that is our build, the contents of this file. And that's real easy, right? When you have just one person with one file. But what happens now when you have 2 files or 10 files, right? Because as an individual developer, I may be responsible for creating and maintaining 10 or 15 different files, depending on how the program is broken down. And normally there is maybe 20, 30, 40, 50 other developers also responsible for tens of files for their area of the application. So now you have hundreds and sometimes even thousands of files that are spread out all over the place. How does this work? How do we get all of those files together into one executable? Well, we do the same thing. We use the compiler. So obviously we have to have some way of knowing what all of the files are and where do they come from, where are they stored, how do we get them all together, and how do we package them all up. Now, the way this normally works is, let's just say in our simple example, we're going to say there are 3 developers. There are 3 programmers that are working on this project, and each programmer is working on a particular portion of the game. As programmer A finishes their work and they need to compile it, they won't have the other code from programmer B and programmer C. Programmer A only has the code that they are working on locally. And so what happens is programmer A will know that their code works and they can test their code, run it all locally. When I say locally, I mean on their local machine. So programmer A is building everything on her machine and everything is working great, but she has no idea if her code will merge well with programmer B and C. So the typical way we handle this is what's known as a source code repository. And the source code repository is where the development team keeps the code and generally all of the assets that go into the game. Now there may be more than one repository, but for this simplified example, we'll just leave everything as one main repository. All right, so the whole point of the central repository is when programmer A is done with her code, she needs to get her code to programmers B and C. Well, how does she do this? Well, she takes her code and she commits it to the repository. And then programmer B and C will pull code from the repository and they will integrate their code with the code that they just pulled down from the repository. So long story short, the latest version of the code is always in the repository. And if you want to add to the repository, you pull that code down, you add your changes to it, and then you push back up to the repository. And this will happen hundreds of times in a day. Every time you do that, assuming continuous integration is set up, which it usually is, especially with modern development, so that will then trigger a build. And you will have a build pipeline and a build chain and all of this good stuff. The end result of that is an automated build. Now here's what happens. So the process of compiling your code into an executable, that is what the build is. But there are hundreds of builds per day, thousands per week. Each build, therefore, has a number. Every time you build the code, or every time the continuous integration system builds your code into an executable, it automatically generates a build number. And the whole point of the build number is so that you can keep track of what features and functionality have been added to a particular build. So you will know build 7 has the shotgun in it while build 6 does not. And so if you want to make sure that everyone is using the shotgun, then you have to make sure that they pull down build 7 and then they start building their work or adding their work on top of that, right? So long story short, you push all of your changes to the repository. That will create a new version, and everyone else then will be out of date because they don't have the latest version of the build anymore. So in order for them to add their work to it, they have to pull changes from the repository, add their changes to it, and then push it back up. This is called version control, and it is a very important process to the software development chain. So now once this happens, okay, you got all these 3 developers and they are building code and pushing it to the repository. So what happens now when, like a tester, so we have a QA person and they need to test it. And they need to test that the latest AI works. And let's just say that programmer C is over here and he's working on the AI. Well, he has to make sure that there is a build ready for the tester to test the latest AI changes. So what he would have to do then is push his code. The build system will do all of its magic, create a build number, usually with some build notes, and then the tester can know, okay, this version of the code has the changes for the AI that I need to test. Okay, so that's just code though, right? That part's pretty straightforward. But there's more that goes into a game than just code, right? So we have the art, we have the music files, we have the voice recording, assuming there's voice acting, and the voice files. We have text files for like subtitles and things that will appear on the screen. We have the character and the character animations. We have the levels and all the level design stuff that's required for that. And like I said, the artwork, which would include textures and buttons and all the other little fancy things that you see in the game that's art related, that's not a texture. All of this stuff has to be bundled together into a single executable. The build contains all of these things to run your game. Now, if you remember from the previous video, when you build for a different platform, so let's assume this is a multi-plat game and they're building Bunny Hop 5, and let's just say that they have a PC version, they have an Xbox version, they have a PlayStation version, and they have a Switch version. They're going to need separate builds for each one of those, because the same code that runs on the Switch cannot run on the Xbox. The same code that runs on the PC will not run on the PlayStation. So they have to have different builds in order to have executables for each of these different platforms. So what do these builds share? Like, what do they share in common? What's different? Because as we discussed before, there's different calling conventions, there are different opcodes, there are just different processors, different machine languages. So you can't just say, take this build and run it on that platform. You have to make a build specific to the platform that you are targeting. And that's where dev kits come in. We'll do a video later about dev kits, but for now, it's important to understand that you have to target a particular platform and you make a build for that platform. But you want the same functionality in each build. So even though there are 4 different targeted platforms and 4 builds, you still want a sense of commonality between those builds, because the AI, you pretty much want that to be the same. You want the physics models to be the same. All of these types of things, the store, the economy, how much an item costs, where the vendors are, like all of these things will remain exactly the same, because that's part of your core build. And you only need to change the pieces that are specific for each platform. So your core repository and your core code tries to be as platform agnostic as it possibly can. So a build then is this whole process of gathering all of these different pieces of work together: the software, the art, the music, the level design, the animations, the character designs, all of that good stuff, the voice acting, all of that stuff. We want to take that, bundle it up. We need to compile it, bundle it up into one executable that can be ran by the loader on a target platform. So that is the build. It is a culmination of everything that's required to run the game. There are thousands of builds, but all of those builds don't make it to the public. And so what you have to do is the team will get together and they will decide which one of these is the official build. And again, they use version numbers. They'll say this is version 1. They typically use semantic versioning because it has more than one part to the number. So it'll be like 1.1.2, or sometimes you see 1.1.007332, just some long number at the end. That's because out of those thousands of builds, this is the one that they have blessed as the official build, and that's how they keep track of it in the version control system. And then they want to add to that, they make sure that everyone starts with that baseline and they add all of their changes to that version of the build and then keep going forward. And a lot of times in this process, features get taken away. There are times when a particular feature was part of the build, but they'll need to remove it. So then they'll need to rebuild everything again, removing specific features. Sometimes the artwork will change. They'll have to recompile and rebuild everything again because the art changed. So one important aspect is that anytime something changes in the game, the entire thing needs to be rebuilt every single time. Now, using dynamic linking, there are ways to mitigate this and get around it, but for the most part, in its purest form, if anything in the game changes, you need a new build. Everything must be rebuilt. And again, just for clarity, depending on if you use dynamic linking or not and how your game is set up with the distribution of files and data, you may be able to just recompile or rebundle certain parts, certain assets. But at the end of the day, it's going to be a new build and a new version number to account for the things that have changed from the previous version. So that's what the build is. The build is the complete set of code and assets required to run the game. Okay, that's it. Time for the quiz. Okay, time's up. Quiz over, pencils down. How did y'all do? Now, hopefully after this guy here, everybody understands a little bit better now about what a build is and the correlations between all the different builds and how all that good stuff happens. And hopefully you'll be better prepared now to go out and have conversations about this kind of stuff. If you enjoyed this video, go ahead and leave a like to let me know that you want more of this particular type of content. Also, if you are enjoying all of the content at the site and you're learning and you're finding the education useful, then go ahead and subscribe to the channel. Hit the notification bell so that you can then be alerted when a new video drops. I'm gonna start calling these knowledge drops, right? So every time we have a new knowledge drop, you can be notified if you subscribe and hit the bell notification icon. Share the video, tell all your friends, neighbors, but only do that for people who you think will benefit from the knowledge and who want the knowledge. Not everyone wants to be educated, right? So make sure that you are sharing the content with people who will actually want the knowledge and who will benefit from it. All right, y'all, we'll see y'all next time. Peace.